Hello, I welcome you all to this another interesting screencast, and the problem reads, express the moment of the couple acting on the pipe assembly in Cartesian vector form. Solve the problem. In A, we have been asked to use this equation. I'm sure it is R cross F, right? Okay. And in B, we have been asked to sum the moments of each force about point O. Given F is equal to 25 newtons. And in case 2, if the couple moment acting on the pipe has a magnitude of 400 newton meter, determine the magnitude F of the vertical force applied to each range. This problem is coming from the Engineering Mechanics Statics textbook, the 10th edition by R.C. Hibbeler. Right, so we can solve these particular problems either using the vector approach or the scalar approach. Okay, and it's up to you to choose which approach to use given what the question is asking you, and if they will not specify, then you can always choose. For us, what method are we going to use? I think we'll use both of them quickly. Let's use both of them. So this is case 483. All right, so let's start with the vector approach. Right, so for the vector approach, we need the lever arms. From the point where we want the moment to the line of action of the force, like so. So we have one there, we have another one there. All right, okay, then let's call this force here. Okay, so we have this is our R, this arm as our RB, okay, and then this arm as our RA. All right, and then let's call this particular force here, let's call it as FA. We know they have the same magnitude but opposite direction. Sorry, that one we call it FB. Let's call this one as FA. The reason I'm doing this because they have opposite direction and we want to use the vector approach. So we know that a moment about O will be equal to RA cross F plus cross F, like so, plus RB cross FB. Let's find what these lever arms are. So we have RA. What are the coordinates of point A? The coordinates in the x-axis, that's 200 plus 150 plus 300. This is 650. Converting into meters is 0.65 I. And then we have plus. What are the coordinates in the y direction for A? Is 400. In meters is 0.4 J. Let's find also the lever arm for RB. The coordinates for RB. We write it as a position vector or vector arm. RB, what are the coordinates? Is 300 in the x, which is 0.3 I, plus 200 in the y, which is 0.2 J. And what are the forces? FA is just going to be equal to minus 25K, and FB is equal to positive 25K. All right, So this therefore is going to be equal to, let's use this tools. We use these tools and then work out our problem. Alright, so let me just move it a little bit up backwards so that we save on space. Alright, there we go. So vector moment about point O, we have I there, j, k, we have I, j, we have I. Let me move this also so that we have a little bit of space. I, j, k, j, k. Okay, so let's plug in. We have the RA is 0.65, then we have a 0.4, then a 0, and then FA is just minus 25, so it's 0, 0, minus 25. The other one there, RB, is 0.3, 0.2, then 0, then 0, 0, 25. Right. Can I move this maybe somewhere here? I move it there like so. Okay. I can even put them in a circle so that they don't disturb any data there. Right. So let's now do the multiplication. We have I there. In the first case, I, then 25 by, where's my calculator? That's a minus 25 by 0.4. It's a minus 10 here. Okay, then minus j. J, what do we have? That's minus 25 by 0.65. This is a minus 16.25. Then plus k. Plus k. What do we have? That's a 0. Then plus this is the first bracket. Okay, then plus I there for this one is 25 by 2.2 by 25, which is just a 5, right? And then we have minus j, that's 25 by 3, 25 by 0.3, that is 7.5. Then plus k, that is just a 0. So when we sum up all this, we'll find that this is going to give us, this is going to give us, if we summed up everything, this will give us that's minus 10 plus 5, that is minus 5, so this is minus 5i, and then plus 16.5, that's plus 16.25 minus 7.5, this gives us a plus 8.75j, and the units for this is Newton meters. Alright, so this is the solution for first case, case 4-83, and then in B they're asking us to find the individual individual moments due to the individual forces about all, which are already there. So say moment due to, you can write them down, these ones you already have them. So say moment about all due to FA will be equal to, we have a minus 10 I, and then we have a plus 16.25 J, and then all this is Newton meters. Then we have moment due to FB, and this is equal to the 5I minus 7.5J. Okay, let me write this properly. 5I minus 7.5J. Okay, Newton meters. All right. So let's use another approach, which is the scalar approach. Okay, the scalar approach. So we have moment about point O. We'll write it also as a vector. Even when we are using this, we are going to sum them up in advance. You'll see what I'm talking about. Okay, because we've been told to represent this as a vector. So say F, this F times the moment around the x-axis due to F. So we'll have F times the lever arm about the x-axis. So we'll have F, which is a 25, and this one is giving us a positive in that direction. So we'll have 25 times the lever arm, which is 200. Okay, and then the other F about the x-axis is going to give us, giving us a negative, so it will be minus 25 times the lever arm, which is 0.4. So all this we can bracket them and then give them a direction along the I. So we'll say plus the same F, this one here again, moment about the y-axis is giving us a negative, that is 25 times the lever arm, which is 300, 0.3. It's giving us a negative. So let me move this so that I put a negative somewhere there. Great. And then I'll say plus this other one is going to give us a positive. It's giving up a positive, so we'll have a 25 by the lever arm, which is 650, 0.65, and then we give it a direction. So if we were to sum up all this, it will give us, it should be able to give us the same solution. So this is going to be equal to, that's 25 by 2 by 0.2 minus 25 by 0.4. So this gives us a minus 5I, and then the other one there we have 25 by 0.65 minus 25 by 0.3. So this gives us a plus 8.75 J. So we have the same solution, we have the same solution whether using the scalar or the vector approach. Okay, so this is again our A. It's the same. Alright. So let's go to case number, the second case, which is case 4-84. Right, what are we being asked here? We're being asked to find the couple force F if we have the magnitude of our moment 400 Newton meters. So again, we can use either the vector or the scalar, or just multiply directly the distance between A and B by F and equate that to 400, right? So for this, we are going to use another approach. Okay, so we know that moment, if we are to write moment, this moment, okay, is equal to mx, okay, I plus my j plus mzk. All right, but we've already been given the magnitude, okay, which is equal to 400. All right, so we can just find that this component, we can square them and then sum them using Pythagoras and equate this to 400. All right, and then later on make F subject of formula. Okay, this is where you use either the vector or the scale analysis. But I want us to use another technique. This is where we just do the direct multiplication of the distance, because this distance between these two couple forces is perpendicular to both these forces, so we can multiply directly. And we know the distances for this. We know already. We know this information here. We have this line here. Okay, this line here, like so. All right. Great. So we have that. So we know the length. The length for this side here, it is that's 200 plus 150. So this is 350. Okay, and if we were to write it in meters, we write it as 0.35 meters. This is this distance here, right? And the distance here for this one here is equal to 400 minus 200, so it's 200, so it's 0.2 meters. So if we know that, then we can find this distance here. Okay, you can find this distance here. Right, so this distance is going to be equal to, using Pythagoras theorem, this distance here is just equal to plus 0.35 squared plus 0.2 squared. Right, so this is root of 0.1625. Okay, so that is the length of AB. So say AB is equal to root of 0.1625. Right, so we know that, therefore our couple moment will just be equal to, this couple moment is equal to F, okay, times AB, which is equal to 400. 400 is already given, and therefore we have F times root of 0.1625 Okay, 1625 equal to 400. And then we make F subject to the formula. Then we'll have found our kappa force. It is this direct. So 400 divided by root of 0.1625, we find that our F is equal to 99992.28 newtons. Right? 400 divided by root of 0.1625, 992.28. This is about it. Let me just outline the solutions. So we have a moment about point O. Okay. And the same technique also can be applied to these particular problems. Okay. We realize that the summation MO itself due to 25, you can also do the same to arrive at the same solutions. Okay. Then we have these individual moments due to each individual force about point O. Then we have F here given the couple moment on the pipe. All right. Great. Of course, the direction of this moment here, it will be, direction of this couple moment here will be perpendicular. The direction of this couple moment, this moment here, which is F times AB, to be perpendicular to that line like so. All right. Of course, this is a free vector, but the direction will not change. All right. This is about it, and I hope the video was helpful. If it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and I'll see you in my next screencast.